Hello, happy Monday night. I know today we had to go to school, but it is Martin Luther King Day, or today we observe the life of Martin Luther King Jr. And a few years ago, was able to go to the Martin Luther King Memorial Museum in Memphis, Tennessee, which is where it's located in the hotel. Actually, they've made it into a museum where he passed away. It's very interesting. If you ever get a chance to go, you should. But there are many things that Martin Luther King did that made our world a better place. And my favorite quote by Martin Luther King is, "Hate cannot drive out hate. Only love can do that." So I think a lot of times in our world we try to get someone back with how they made us feel, and we think that's going to solve the situation, is to drive out hate. Hate with hate right back to them. But that's not how it works. It only makes it worse. So instead of reacting that way, we should drive out hate with love. So anyways, that's my favorite Martin Luther King Jr. quote. Maybe that's going to inspire you today. I don't know, but wanted to share it with you. Alright, tonight we're going to be talking about sequences. So today in class we talked about growth and decay. And so we talked about how some things increase by the same factor over periods of time. We're going to extend on that. And there's a lot of times where you might have some numbers like this, and it says, like, what is the pattern of this number? And then it would say, what would be the 82nd term in this sequence? Well, there's a formula that we can use to figure that out. And today we're just going to scratch the surface of that. So the first thing we want to do when we see a sequence is we want to figure out what the pattern is. So if we can zoom into this pattern here, or these numbers, we can see that from 1 to 4, 4 to 7, and 7 to 10, it's increasing by 3. I hope that you see that. It's an increase of 3. So that's what you have to do first when you see a sequence like that, is figure out what the pattern is. And we, in math, before we work with numbers, we always put it in algebraic form, which can be with a variable like a letter. So each term, this is a term, this is a term, these are all terms. Each term, we call it like this, it's a to the n. So n equals the term number. So this would be n equals 1, n equals 2, n equals 3, n equals 4, and so on. So a number to the nth term. Now, pay attention here. This is a number, when we put the nth term here, this is a subscript because it is smaller than the coefficient, the other number in front of it, the base, if you will. It is the opposite. It's not an exponent. Exponent is a superscript. It's raised up at the top. This is below. So it's not an exponent. So each term, a to the n, is the last term increased by 3. Okay? In this one, it was increased by 3. It was plus 3. So I'm going to draw a line there so that you see the correlation, increased by 3. Now there's a little formula that we can use to figure out how, there's a way we're going to write this. A to any numbered term minus 1. So a to the n minus 1, a n minus 1, increased by 3 in this one. So any term, it could be 5, it could be 7, whatever, it can be found by the rule. This is the formula that we're going to be using today. A n minus 1 plus 3. Okay, in this case it was plus 3. So if we wanted to find out what that means, is if we wanted to find out the 100th term in this sequence here, we could. What we would do is we would say a to the n minus 1, okay, and n minus 1 is, the n would be 100, that's the nth term, minus 1 plus 3. So it would be a to the 99th term plus 3. And we had to solve, we'd have to figure out what a is first. But anyways, all we're doing today, we're not solving, we're just setting it up. Okay? So a to the n minus 1, and then whatever the pattern is what you put at the end. It's very easy. So let's do the next one. 15, 10, 5, and 0. Okay, what's the pattern here? How are these increasing or decreasing? Well, it's a negative 5. You see that, how it's going down by 5 each term? So it's going down 5. Okay, so each term, remember a to the n, it is the previous term, a to the n minus 1, minus 5. Okay, so we keep using this a to the n minus 1 and then whatever the pattern is. So the rule in this sequence is a to the n minus 1 minus 5. Okay, let's go down to the next one. So we're going to find our pattern first. Our pattern is it's increasing by what? By 4. Each thing is increasing by 4. So a to the n minus 1 plus 4. Super easy. Okay. And this one. Ooh, this one's a little higher numbers, but it's not so bad. It's decreasing by 100. So a to the n minus 1 minus 100. That would be your rule for that one. Okay, your sequence rule. Alright, let's look at number 3. If a to the n equals a n minus 1 plus 6, and a to the 1 equals 10, write your next term. Okay, so next 3 terms, sorry. So when it says a to the 1, that's going to be your first term. Okay, so a to the 1 is 10, it tells you. So it's increasing by 6. So we have 16, 22, 28. So you see how we went from the rule, and we were able to write down the numbers this time. Okay, if a to the n equals a to the n minus 1 minus 2, that's our pattern there, and a to the 5 is 8, write the next 3 terms. So we're going to still start with 8, even though it's a to the 5, because all we need is 8 and then the next 3 terms. So minus 2, 6, minus 2, 4, minus 2, 2. You're just subtracting 2 each time. Okay? Alright, let's go to the next page. We have a new sequence. We have 2, 12, 72, 432. Ooh, this one's a little bit trickier. We're not adding or subtracting. What are we doing? Can you figure it out? We're multiplying by 6. Okay? Times 6. So times 6. Okay. So each term, a to the n, is 6 times the previous term, a to the n minus 1. So here's our rule. A to the n minus 1 times 6. Still using the same thing, you just add the pattern at the end. Alright, let's see if we can figure this one out. Negative 4, negative 12, negative 36. What is it increasing or decreasing by? Well, it's times 3. So the rule is times 3. So we have a to the n equals a to the n minus 1 times 3. Alright, we have 100, 50, 25, and 12 and a half. Do you see a pattern here? This one's a little bit different. So they are decreasing by 1/2. Or cut in half, which that actually equals times 1/2, because anything that you multiply times 1/2, it cuts it in half. So let's put that in. A to the n equals a to the n minus 1 times 1/2. Alright, let's see here. What's our pattern on this one? Number 5. 4, 8, 16, 32. We're multiplying by 2. So it's a to the n equals a to the n minus 1 times 2. That's our rule there. Okay, let's see this one. 54 to 18 to 6 to 2. Okay, so it looks like they're dividing by 3. But when we're doing these sequences, we don't want to use division, because then we'd have to put a to the n minus 1 over whatever number that is, because it'd be a fraction. So we're going to keep it in multiplication, and we're just going to say it's times 1/3. Times 1/3. So see if you can write that rule. Pause it and see if you can write it yourself, and then unpause it and see how you did. Is that what you got? If that's what you got, you are correcto. Alright, let's see here. What are the next 3 terms in the sequence? A to the n equals a to the n minus 1 times 5. So this is our pattern. Alright, so we're going to start with negative 2 is what it says, and we need the next 3 terms. So we're going to multiply by 5. Negative 10, negative 50, negative 250. Okay, and last one. Next 3 terms, if we're multiplying by 10, and our first term is 4. So we have 4, 40, 400, 4,000. Okay? Alright, hopefully this is a little easier for you. It's not anything tricky and crazy with new rules and whatever. As long as you get that a to the n equals a to the n minus 1, and then find out the pattern, you are golden. Alright, y'all have a good night, and I'll see you tomorrow.